coefficients or the system. I don't have to specify the matrix of the free terms. So I can right now go right ahead to the augmented matrix. Good. So remember, we only have 3 operations allowed here. So the first one is already done. I mean, the first step is already done because it happens that I have 1 in there. So I will be using row 1 and multiplying it by and adding it to row 2, and also row 1, multiplying it by something and add it to row 3. So you'll never make a mistake if you remember that first we use row 1, then we use row 2 to eliminate something, and then we use row 3. Good. So what will I multiply 1 by to eliminate 2? And that will be the number here. And what will I multiply 1 by to eliminate 3? And that will be the number here. Very good. So let's see what we find. Which row I have to copy because it will not change at this point is the one that I'm using. Yes. 1, 0, -3, -2. And now let's see what we get. 1 times -2 plus 2. Very good. 0 times -2 plus 2. How much? 2. Very good. -3 times -2. Positive 6 plus 1, 7. -2 times -2 plus 4. Very good. 1 times -3 plus 3. Very good. 0 times -3 plus 1. -3 times -3. 9 minus 2. Very good. -2 times -3 plus 5. Perfect. Now let's take a look what we need. First column is done. What is the next step? Yes, because it's already there. Otherwise, if it would be easy to divide both sides, I will divide both sides by 2, or this row by 2. But it's not. So I'm going to swap. Very good. So I'm going to show that row 2 becomes row 3, and row 3 becomes row 2. Perfect. So 1, 0, 0 anyway. So 0, -3, -2, 1, 7, 11, 2, 7, 8. Perfect. So it happens now that I have this and I also have this. Nice. I only need to multiply which row by what and add it to which row? Right, by -2 to add it to row 3. Because I already have the 0. Good. So which row do I copy now for sure? Because it will not change. Yes, it happens at row 1 as well because it has 0 already. 1 times -2, 1 times -2 plus 2. 7 times -2 plus 7. Yes. 11 times -2, -22, plus 8. Perfect. Okay. The next step must be getting a 1 in the third row. So I have the third row to divide it by. Very good. So here it is. We copy the first 2 rows. We copy 0, 0, 1, and 2. -7 divided by -7 is 1. -14 divided by -7 is 2. Now, of course, I have to use row 3 twice. What do I multiply row 3 by and add it to row 1? Very good. What do I multiply row 3 by to add it to row 2? Very good. So 1, 0, 0, 1, 0, 0, 1, 2. Final step. 1 multiplied by 3 minus 3. 2 multiplied by 3, 6 minus 2, 4. 1 times negative 7 plus 7. 2 times negative 7, negative 14 plus 11. I have the solution now. Do I know whether it's true? No, not yet. I haven't checked. But I have a solution. It appears that the solution is, in case we didn't, assuming we didn't make a mistake, what is it? 4, negative 3, 2 with a question mark. I don't know yet. Don't trust it. It's very easy to make an error here. Any questions so far before we check? Any questions before we check? Ready? So 4, negative 3, 2. 4, negative 3, 2. 4, negative 3, 2. 4, negative 3, 2. 4 minus 6, negative 2. Check. 8 minus 6 is 2. 2 plus 2 is 4. Check. 12 minus 3 is 9. 9 minus 4 is 5. Check. Now I have to say yes. Any questions? Any questions? Any questions?
Okay, so I saw the order that you've been doing it.
Yes.
Is there like a written out order on how it's supposed to be?
That is the only one.
Okay.
I mean, I can show you how.
We could just go back to it.
You,
Because you had put like 1, 2 on the
Right.
one.
right. I can show you. Yes, I will write it. See, here's how the book presents it. But they're doing it in so many more steps than what I presented. So here they find the 1, and they show that they find the zeros. Then they find the 1, and then they show the next 0, and then the next 0. And this is basically the Gaussian elimination method, not the Gauss-Jordan. So this is a much, I would say, longer method. But here's the sequence of steps. 1 and the corresponding zeros. I'll go back to that page right now. So one more time. 1 and then corresponding zeros. And then 1 and the corresponding zeros. And then 1 and then the corresponding zeros. So let's go back to that sequence that I had before. That's what you're asking, right? Okay. So 1 and then the corresponding zeros. And then 1 and then the corresponding zeros. And then 1 and the corresponding zeros. You always have to start by worrying about the 1 of the column and then the corresponding zeros using that 1. And then you have to continue with the second row, forgive me, with the second column, finding the 1 in the middle. And then that will help you find the zeros. This one will help you get the zeros above it. So this one helps us to get these zeros. This one helps us to get those zeros. And this one helps us to get those zeros. And that.
And if any of the values have a given 1, we just swap it to make it easier.
Yes. Yes, like we had before. So because I don't want to work too hard. And I don't want to, I'm trying to avoid fractions as much as possible. Because if I run into fractions, it's going to be a little bit more involving. Because I have to add and subtract fractions and multiply fractions. And so that makes it slightly more difficult. So that's always the sequence. Start at the upper left corner. get the zeros. Then continue with the corresponding one for this column. In this column, the 1 has to be in the middle because it cannot be here and it cannot be here. So once I get the 1 in the middle, then that will help me get the zeros up and down, above and below. And then when I get this one, that has to be the next step. Then this one will help us get the zeros. Only the one of each column will help us get the corresponding zeros. Better?
Yes.
Any questions? My pleasure. Any questions? Okay, I know I only have about 12 minutes. Let's look at the last section, which is 8.1. 8.1, sequences and summation, also called sigma notation. Sequences and summation, or sigma notation. What does this mean? Sigma notation. It's an easier way of writing, for example, 1 squared plus 2 squared plus dot 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 plus n squared. It's clearly a sum of terms, right? So the notation will be, this is the Greek letter S. Why do we use it and not use the Latin S? It's because it's more convenient. I'll explain why. So first of all, 1 to dot 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 n, this is the general term of the sequence, I squared. From I being 1, this is the lower limit, and n being the upper limit. So in order to avoid having to write something like this notation, sum, there is another one with a product, so this is a sum, S, the sum of I squared from I equals 1, then 2, then 3, then 4, then dot 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 n. Now, can anyone condense this for us? Let's say 1 cubed plus 2 cubed plus dot dot dot. There has to be 3 dots. Not more, not less. How will you write this? You will write it as the sum, or the sigma notation, from I equals through the last one, which is n, from the general term, which will be I cubed. Okay, I would like you to expand this for me. I equals 1 through 5. And here is the general term, 2i plus 3. How many terms will you give me for this sum? When I is 1, 2, 3, 4, 5. 5 terms. Okay, please give me the first term, and then the second term. And then I trust you to give me the last one. Do not calculate anything. I just want to write the notation. Very good. Awesome. The next one. Very good. And the last one. That's it. Yes, we didn't calculate anything. We don't have to right this moment. But this is what it means. Instead of listing them on 2 rows, we have this summation notation that says that's what it is, or sigma notation. That's what it means. What is the general term here? This is the general term, 2i plus 3 this time. Okay, so I'd like to look at a couple of problems before we move on to another concept here. And on page 752, find each indicated sum. So let's start with 31. on page 752. The sum from I equals 1 through 4 of 2I squared. They want us to find this sum. Okay, how many terms will the sum have, or the summation will have? 4. Very good. The first one is 2 multiplied by. The constant, you can put it outside, but that's okay. That's one of the properties of the summation notation. So I can rewrite it as 2 because it's a factor. Sum from I squared, I equals 1 through 4. And multiply all of them at once at the end. So what will be the first term? Good. The second one? Very good. Very good. So this is 2 multiplied by 1 squared, 4, 9, 16. So this is how I would like to add 20 and 30. 4 plus 16 is 20, 9 plus 1. So this will be 2 multiplied by 30, which is 60. Any questions? Okay, now we are given the expanded sum, and they want us to come up with, so this is 46 on the same page, 752. So 5 plus 5 squared plus 5 to the third plus dot 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 plus 5 to the 12th. They want us to use the summation or sigma notation and replace this. What would you say? From I equals 1 till, very good. And obviously all these terms have 5 as the base, so they all have to have 5. And what about the power? Exactly. So this is the condensed one. When I is 1, I get 5. When I is 2, I get plus 5 squared, and so on and so forth. Perfect. Any questions? Okay, I would like to talk about what is called factorial notation. Factorial notation. For example, 4 factorial. The factorial notation is the exclamation mark. 4 factorial. By definition, this is 4 multiplied by 3 multiplied by 2 multiplied by 1. So 4 times 6, this will be 24. By convention, 1 factorial is 1, as well as 0 factorial is also 1. In general, what about n factorial? It's n times n minus 1 times n minus 2 dot 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 times 1. Okay, I'll show you the factorial notation in the calculator in a minute, but I would like us to simplify. 24 on page 752. We are given 18 factorial. Everything divided by 16 factorial. Well, this is big, right? 18 factorial is 18 times 17 times. However, look at these two numbers. This is 18 and this is 16. So this is what I am going to do. 18. What is the next one? And the next one, and I'm going to stop. Why? Because I see 16 factorial in the denominator, and I'm going to do this. I don't have to go all the way. So I will stop I will see which one is the smallest, and I will start with a bigger one and then stop at the smallest one. So whatever 17 multiplied by 18 is, and that's the answer. So it's 306. With a graphing calculator, you don't have to do this. I knew that I was missing something. So here's the symbol, the factorial notation. So we had 18 in the math. Go to numbers. It has to be in probability. Probability 4. So stop at probability and select item 4. Divided by, I would put parentheses. You know me. I probably should put parentheses already in there. I'm going to do that. So 18, math, probability, number 4, close the parenthesis, divided by parentheses, 60. I don't know how the software will take it, so I'd rather be safe than sorry. Okay, number 4 again, close the parenthesis. And when I hit enter, what should I get? Okay, so you can do this directly with a calculator. But why? Since so from I would like to do 21 because we have, oh, we only have 1 minute. So choose one problem from this handout that I gave you today, either 21 or 22. And we'll stop. Which one? 21? Okay, so let's take a look at 21. We have 3n plus 2 factorial over 3n factorial. Now, which one is bigger? And that's where I'm going to start. 3n plus 2 is bigger. So then I will write 3n plus 2. What is the next one? Very good. What is the next one? Yes. And I'm going to stop because I see the denominator as being 3n factorial. So 3n factorial, I'll cancel these two, and I'm done. It's 3n plus 2 times 3n plus 1. That's all we need.